Thank you, everybody, for coming on a pouring day. Well, the FCC has given amateur radio a great gift by letting us have this field day and giving us all licenses, permission to use spectrum. And one of the things we try to do is we try to educate ourselves so we don't do anything bad on the air with our radios and cause any interference. So they have the WRL as an educational reward. You get 100 points if you put together a program to teach something relative to radio. That might help you, particularly in technology, make your radios run right. So for 2023, the club asked for a program, and I volunteered because I didn't step back from the line fast enough about to help people figure out, is your digital meter really telling the truth? I mean, how can you fix a radio if you don't know if your tools are working right? And this is a really interesting problem. Does your meter really tell the truth? And how would you know? We all use these multimeters. Everybody's got one of these $5 meters somewhere in their junk box. We hook them up and we believe them. But how do you know it's telling you the truth? Well, you could buy two of them, and say, oh, okay, I've got two of them now. Oh, wait a minute. They don't exactly agree. Which one's right? You could end up with an example of the annoying Siegel's Law. Does anybody here know Siegel's Law? I didn't either until I started doing this presentation. Siegel's Law. See the guy in the right with two watches? A man with a watch knows what time it is. But a man with two watches is never sure. Just like having two meters. Which one would you believe? So yes, it can be adapted. And I'll tell you, you may have one meter today, but eventually you'll have another one. Because you'll want one that plugs in, you want one with more digits, but you really don't know, are they telling the truth? So which do you believe? Now here I have 3 meters. You can see them, here's one of them. The other 2 are over there, all hooked up to the same signal, and they're all giving different numbers. Now suppose you're troubleshooting something, and the book says you should find 12 volts here. But meter A says 13 volts, meter B says 11 volts, meter C says 12. Is the radio broken, or is the meter broken? This happens in the real world, as I can demonstrate. And what about that meter you picked up at the flea market? I mean, come on, who doesn't love a bargain, Oh, I got this $3,000 Hewlett Packard at the flea market for 20 bucks. Well, okay, it lights up. It says something, but how do you know it's proper? Are you going to send it back to Hewlett Packard for a calibration? If you're full of money, yeah, I got extra money, maybe. And everybody loves these cheapy $6 meters, which are sometimes free. But how can you possibly believe them? I mean, it says at the ad, and you know Harbor Freight's got to have it, right? Digital multimeter makes precision electronic measurements and tests for $5.99. I mean, really.
Or on occasion free.
Yes. Now, I got to tell you, those other 2 meters aren't $5.99. So, what does the factory do? What does a reputable manufacturer? Not necessarily these guys. But what do they do to make sure their meters are right? They calibrate the product. They put it on a bench, and each one goes through. They plug it in, and they look up. This should be 5.0000 when I set this to 5. And that's great, but those lab grade benches are megabucks, well beyond our radio money. So what can we do? Well, there is a reasonable solution, and it wasn't too hard to find. Instead of kicking my pile of meters because I couldn't afford a calibration
The 706
device,
your radio for 20 meters? 706.
2 old friends, YouTube and EHAM, I located a popular solution.
Hey, Ray, you're QRMing the lecture.
Sorry,
A little device called the DMM check, which is actually made for hobbyists to do calibration. And you can see the little cartoon here. I love this one. Nobody's on the air. The bands are dead, I tell you. There are no sunspots, and FTA has ruined their radio. You should try calling CQ. Sometimes the solution is easy if you just ask your friends and look around. So this is the DMM Check Plus. You've probably seen ads in QST or some pop-down ad, an e-ham or something like that. And it gives you voltages, standard voltages that you can measure in DC and AC, current in DC and AC. It's got a set of resistors that are calibrated, and they have the exact measurements right there where they came from at the factory. And you can take your meter, you can walk through each test point, and then write down what your meter says versus what the factory said. And then walk away knowing whether your meter is close or far. And if it is far, you know how far, so you can work around it. You can keep in your head, I'm measuring 10 volts here, but my meter says 10.3, and that's okay, because when I checked it against a 10 volt standard, I wrote down that it really, even though it says 10.3, it's really 10 volts.
Who makes that device, Mike?
It's called, there's a name on here. It's like Voltage Precision, dnmcheckplus.com, but that's not the actual name of the company. I've got the brochure here. We can take a look at it. But how do you know these guys did it right? I mean, I could put together something. A couple of you guys have asked me, did you build this? And I could have. John could have built it. Richie could have built it. But I wouldn't have the parts of precision. And then when I was done, I wouldn't have anything to test it with that was accurate enough that the results were believable. Where this is made, look at the digits of this display. 1, 2, 3, 4, 5, 6, 7, 8 to 9 places this meter can read. So the gentleman that builds these, when he's done, he tests them out, fills out this place called a calibration certificate, writes down all the models of test equipment he used and the serial numbers, the day he did it, the temperature, the humidity, whether he's getting good stereo reception, everything. And here it is. So the goal is to see if you can duplicate these numbers with your meter. If you can, you're out of the woods. If not, maybe we should come up with a plan of action. So, to do that, you have to turn this thing on, let it sit for 15 minutes. Why would you do that? Anybody have an idea?
Stability?
You're right. You let the thing, like a day like today, it's humid and it's warmer than my basement probably. And things have to settle in. Now, in all honesty, with our meters, it probably doesn't matter a lot. But if somebody walks in here with something pretty snazzy, it might. It might. And he even gives you a correction factor if it's like you're in extreme temperature. But you're supposed to let it warm for 15 minutes. Let your meter warm up for 15 minutes. Now, for me, when I take out my meter, I go use it right away. So I wouldn't worry too much about that. So I printed out a table like this that you can fill out for your own meters. I want you to put down the make of your meter, the model, the serial number, the date, and who owns it. Then the first thing you would do is you put your test probes on the 2 terminals that say voltage. Read it out. Greg did this already in his meter. And he got 5.00 volts, and he wrote that in right there. So he knows his meter reads properly. We went to AC, where it's supposed to be 4.999, and he came up with 3.8 something. And we played with it for a while, and we really scratched our heads. We said, well, let's write that down and move on. We went to current source. We measured 1 milliamp. That worked okay. We measured 1 milliamp of AC. That worked okay. And we went through all the resistors, and they all came in place. He didn't have any capacitance or inductance capability to measure that, so he didn't do that. So then we went back to that AC voltage, and it worked. And then we quickly figured out that we were on the wrong terminals. But it's a good troubleshooting step. You can tell right away, are you making an operator error? Or you have a piece of test equipment that's bad? Real quick. What else could you do with this thing? Well, like I said before, you could troubleshoot whether it's the meter or whether it's you. And when you're trying to check the current rating on a meter, that's when they blow up their meters. How do I know that? There's a blown 2-amp fuse in that meter over there. It's too easy just to hook a voltage source, a power supply across the meter and see I didn't put a resistor in line to limit the current. And but the fuse fortunately saved my day. So you won't blow up anybody's meter with this. What else can you do with it? You can determine, is the meter really broken or is it an operator error? Like I mentioned before, Greg and I had an operator error. And I'd rather have that any day. It's much cheaper than blowing up equipment. You can check out the flea market meters on site. if the meter has batteries, like somebody's trying to sell you a cheap meter that's got batteries in it, and you got this in your pocket, excuse me a second, ding, 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 ding. You better give me half price in this meter. It's off by 35%. You could check a meter before you take it home. You can make friends with this meter, this gizmo. You can lend it to your buddies and say, hey, you want to test it? No problem. You can lose friends with this gizmo. How can you do that? Well, if you got a bad attitude, you go around and say, my meter's better than yours because I got this. Don't do
That looks like me with D-Star.
that. Yeah, that's Greg, actually. No. So let's give it a try. If you brought a meter, let's use it. If not, pick one of mine. There are blank copies that you can fill out. And I appreciate you watching. And I think this is pretty much my shack, anybody who's been there. There's my transceiver, and the rest of that is my test equipment. So thank you. I hope that covered enough time, Gil.
Absolutely.
And I hope you earned our 100 points.
Thanks,
Yay,
Mike.
thank you, Mike.
Any questions?
Now, quite often when I'm doing home brewing stuff, I will use a voltage regulator, like I think 78L05
Right.
or 08 or 09.
Yep.
12 volts, and then getting the 5 volts or the 8 volts or the 9 volts out of it.
Yep.
Would you estimate how accurate those are?
Well, they'll tell you in the spec sheets. National invented those devices, I believe.
Oh,
In the
okay.
spec sheets will tell you that. But the device inside here is related to that.
Oh.
It's called a buried Zener regulator. I didn't get a chance to Google that. Does anybody know what that means? Buried
Say it
Zener?
again, Mike.
B-U-R-I-E-D, like you bury something. A buried Zener regulator.
It's the way the silicon is formed.
A little louder, please, Aaron.
It's a trench in the silicon. That's why the zener is buried.
Oh,
Oh.
now how does that help it be more accurate?
It's just the way it's fabricated. It tends to work.
It's a
out.
high stability way of fabricating a Zener diode. Okay. Well, there's a chip in here that's got that in it, and it's a very low current, buffer after it, so it doesn't draw any current off it.
Right.
And then it's calibrated, and away you go. Was there another question back there? Go ahead.
How accurate is the little box?
I'm
How
sorry.
accurate is the little box?
Too much. It's not $5,000. It was originally $99, and I bought this option card, and I bought the case, and that gets you to about $150. Now I know that seems like a lot, and it is, but there's just nothing cheaper that I know of.
Is it in Q Street?
It was for a long time. I couldn't find the ad. I want to copy it for here. It's in nuts and bolts. It's in some drop-down ads like in QRZ and stuff like that too. And for years I looked at it. I couldn't come up with an excuse for it. Then one day I did what that girl in the Charlie Brown thing. I was so mad at my meters I was ready to kick them. And just broke down and bought it. And now it's a popular device in my house. With all the hands in my family.
Yeah.
So how accurate is it? Like a tenth of a percent kind of, or better?
I'm bringing all my meters over to your house.
Yeah.
That's the idea. That's it. You can bring them over. 5.0000.
Yeah, good 5 digits. That's good.
5 digits is pretty darn better than any meter I own. So does anybody have a meter they want to set up or test? Well, maybe later.
Do you gonna be here tomorrow with that thing? I've got to bring mine.
So I'll bring mine tomorrow morning.
Yeah. I don't. Luke
I'll be here tomorrow morning. Yeah.
Yeah, I know. I gotta check mine too.
And I could bring it to a club meeting too.
Yeah.
Yeah, good
That'd be
idea.
cool.
Go ahead.
Is this also subject to Seagull's law?
I'm sorry, I can't hear you.
Is that a subject to Seagull's law as well?
Is that a subject for what?
Set to Siegel's law.
Yes.
If you have two of those.
Too bad you couldn't find
I'm
a way to
trying to-
do this online.
I'm trying to
It's
talk
gonna
Greg
be
into
online.
coming up with a calibrator for power meters, for 100-watt power meters.
Lena's got it online right now. You can go back online
And,
and see it tonight.
Yep.
That's our next challenge. We want to come up with some way we can do a presentation.
Actually test the
where
meter.
we can bring in a 100-watt transceiver and meter it accurately enough so that you can check all your watt meters. 'Cause I've never seen change more. You put 2 watt meters in line, even back to back, and they're different. And Greg hasn't come up with the idea yet, but we'll work on it. Milliwatts is easy, but as soon as you put anything amplifier in line, it's hard to calibrate it. You need something to step it back down, and there's got to be a way. There's got to be a way to do it. Anybody else?
Well, thank you, Mike.
You're welcome. It was fun.
Thank you.
We shall
Thank
see.
you.